all set. Get to know this pretty little bird. If your little bird is not perching on your taskbar like this, then you have to watch my previous video, episode 14, setup Intel TBB 2020, the older version for Pro TBB, by clicking this link. Double click it. In this playlist, C++ 17 2023 CUDA SQL OpenGL TBB, you are supposed to watch all the videos listed in sequential order, especially episode 14. You should have installed Intel 1 TBB 2020. Otherwise, you may not have this little bird perched on your taskbar. Hello everyone, my name is Thomas Kim. This is my 15th episode. We will learn Fibonacci Sequence parallel invoke task group. If you double-click this link, you can download 172 megabytes zip file, Intel TBB 2020 zip. It says it takes 1 minute to download this file. When download is complete, click this button, Show in Folder, unzip it, extract to Intel TBB 20, double click it. In this folder, you can find this pretty bird. She's so pretty. You can also find Pro TBB Master. This folder includes sample file, chapter by chapter. In chapter 10, you can find figure 1004.cpp. These are all sample file. Fib or Fibonacci sequence, parallel Fibonacci sequence. You need this Pro TBB master sample code. Also, Intel TBB PDF. In this PDF, we are covering task scheduler. This is chapter 9 task scheduler. If you scroll down, you can find some information. Also, explanation about Fibonacci numbers, how we are going to implement serial Fibonacci code, parallel Fibonacci code. In my next episode, we will be using Intel TBB task allocate route. We are going down internals of Intel TBB. Also, Pro TBB in this book, chapter 10, using task to create your own algorithm. We will cover chapter 10. Scroll down. You can find Fibonacci sequence example. We will implement this part of code. Fibonacci sequence is defined with recurrence relation like this. We will also learn how to implement parallel Fibonacci using parallel invoke. Then we will implement Fibonacci sequence using task group. So we can implement parallel Fibonacci using TBB task group. In my next episode, we will implement Fibonacci sequence using low-level task interface. Here, we are using low-level task allocate route to implement parallel Fibonacci algorithm. We are going down deep into the internals of TBB task. If you are interested or you think you are a hardcore programmer, then you deserve to watch my current and future videos. If you think you are a casual programmer, you can still watch or observe my journey or voyage into the world of Intel TBB. Without further ado, let's get started. Fire up your Visual Studio Code. Open up your folder. Click this button, 015 TBB task. Click this button, task.cpp. Hit enter. Ctrl B. Include talkplay fun. Output HBP. Talkplay fun. SStream. Print. Auto. Ender. Talkplay fun. Ender. Auto. NL. Talkplay fun. NL. Carriage. Return. Then flush out to console. Carriage return. Without flushing out to console. Void. Serial fib. Long n. If n less than 2, that is, n equals 0 or 1, then we simply return n. Else, return serial fib n minus 1 plus serial fib n minus 2. Void parallel invoke fib. I would make it template long cut off long n. If n less than cut off return, we are using serial fib n. Else, TBB parallel invoke. We provide two jobs here, long x Y. Uno. Left. We capture by L value reference. Long N. We also need to capture. Sorry, I will capture N like this. Then X equals. We are calling this function recursively. We have to pass cut off as template argument here. Then n minus 1 semicolon, copy, paste, right. We capture y, then n minus 2. We created two tasks, left and right. Left, right. Then return x plus y. So we are computing pib n minus 1 plus pib n minus 2. Now into main. I'm very sorry. I made something very stupid. Return type should be long. Also long. I would change this lambda name fn1. Also fn2. Here fn1, fn2 is much easier. Or fn1 plus fn2. Void test parallel invoke fib. Copy this function name in the function main. Context per long cut off 20. Please note that this cutoff will be used in this function as a template argument, so it should be compile time constant or context per long n 30 auto t0 TBB tick count. Now we are timing long serial f n serial fib n auto t1 TBB tick count. Now auto time serial t1 minus t0 dot seconds. We are computing elapsed time for serial fib n. I would copy, paste T2. Now invoke Fn parallel, invoke fib. We have to provide template argument here. This cutoff and fix like this. T3 time invoke T2 T. This is T3. T3 minus T2 elapsed time for parallel invoke fib with cut off. Now print serial fib elapsed time serial seconds NL. Copy, paste, parallel, invoke, fib elapsed. I will arrange like this. Time invoke like this. Print serial parallel ratio. Time serial time invoke. Now and L. We have to flush out here. I will add one more line of code here. Serial Fn. This serial Fn. Invoke Fn like this. NL. Now whistle to your bird. CD 015 TBB task CLEHSC SCD C++17 task.cpp fe m.exe. Hit enter. CLS M. So serial parallel invoke result is the same. Serial parallel ratio 1.6. Not much gain. I would make it 10 and 40. Let's try it again. CLS M. The results are the same. Parallel is 3.9 times or 4 times faster. We can change this cutoff to 20. We can test in various different ways. Now, parallel algorithm is 10 times faster than serial fib. I originally planned to explain task group. This session become too long. I will explain task group in my next episode. Please read this book, Parallel Pip using Parallel Invoke, Pro TBB.